repeat myself. I just wanted to go over a few logistics before we get started with the webinar. Thank you all for being here. So today's webinar, you can find the full report as well as a one-page infographic and four-page findings at gsa.gov. The webinar will be recorded and slides will be available on gsa.gov as well as links for upcoming webinars. The next webinar we have will be on June 20th. It will be another webinar on submetering and analytics, circuit level submetering and analytics featuring wireless current transformers. These are small CTs that clip onto the outside of the electrical wires in the panel and draw power from the current running through the wires. The National Renewable Energy Laboratory will report out on this assessment of the wireless CTs that were tested at a test bed in Denver, Colorado. Today's webinar does offer continuing education credit. To receive credit, you should all receive a post-webinar survey if you registered for the webinar. If you don't receive the survey, please reach out to Michael Hobson. Now, you should be able to hear me, but you all are set to listen-only mode. So if you wish to submit questions, please put them here in the lower right-hand corner of the chat window, and you don't need to wait until the Q&A session at the end. In fact, we encourage you to submit questions well in advance of that. And with that, let me introduce Mike Lowell, who is our project manager and will be facilitating today's webinar. Mike.
Thanks, Andrea. Next slide, please. And here on this slide, we have the agenda. After my introduction, Kevin Powell, our director, will give you a summary of the Center for Emerging Building Technologies program. After that, we'll have Dylan Cutler with NRail, who is the primary investigator for this study, who will give you a presentation of the summary results of our study. After that, we'll have, this study was in Region 8 of GSA. And after Dylan, we'll have Tyler Cooper with Region 8, who will give us the perspective from Region 8 and the users of this technology. And then lastly, we'll come back to Dylan and he'll give you a lay of the land summary. This technology space actually has quite a few different versions of smart submetering, low-cost smart submetering, and comes in many forms and fashions. And so Dylan will give you kind of a summary of what we found in the technology space. After that, we'll have a Q&A for 20 minutes and we'll wrap up. With that, next slide, and I'll turn it over to Kevin Powell.
Well, thank you, Mike. And so first, just a couple of words about our Emerging Building Technologies program and why we have that program. I think all of you who are on the call are well aware that we have an awful lot of real estate. We have very efficient buildings. We're constantly being challenged to do more with less, and most people agree that the best path to doing more with less is essentially innovation. Question with innovation always is great new idea, seems like it has a lot of possibility, but does it actually work? And that's what the Emerging Building Technologies program is all about. So the Emerging Building Technologies for GSA looks to the best of the best, and certainly that's how these wireless submeters were selected for the program. We don't need to sort of belabor that whole process, but let's just say we have a complicated, involved, transparent, and I think rather rigorous process to identify what's next in the marketplace. Select the best of the best, and then prove it out in our inventory. And the important thing to understand about what the outcome that you're going to hear about on this call is designed to achieve is that we want to understand not just that the technology works, and there is, that's of course critical, but also that it can be installed and operated, deliver performance that we can actually use in the real world of our buildings. We want to understand that it has payback and that it can be operated in a manner that's cyber secure. And so when all of that is accomplished, then we have a technology that we feel can credibly be broadly deployed by GSA. And that's actually what we're going to hear about on this call. So then the next slide. Three key things we think about this low-cost submetering. The first, which is actually sort of, I guess, maybe overarching all of this, is that there's, I think everybody's heard the old Peter Drucker comment that you can't manage what you can't measure. So people have, with that in mind, they have wanted to be able to actually measure the amount of energy consumed by all sorts of building loads. And the challenge has been that metering is very expensive. It's difficult to install, and it's historically has been difficult to install and has been expensive to install. What we have here, and both that we're going to talk about today, and then we'll talk about on next month's call, we have a third technology that's still in evaluation, are some really innovative approaches to achieve that kind of energy submetering at a very, very low cost, or a relatively low cost. And once we're able to do that, then we think these three use cases become very, very achievable. So currently, when tenants are using what we would consider to be energy above and beyond what would be a baseline, we consider that to be overtime utilities, and we do that based on an estimate of what we assume that energy is. This is an opportunity to actually measure that and to engage in something that's much more transparent, because whenever you estimate something, both parties usually feel they're getting the short end of the stick. The second thing that we can do is actually understand when things are on that shouldn't be on. And that's really the key to fault detection and diagnostics. Something is operating in a way that it shouldn't. It's using energy in a way that would be outside of what you would expect. And we have complicated ways to assess that. This might be a much simpler way. And then finally, we install a lot of energy conservation measures, and then there can be either very complicated and expensive M&V to verify that especially when they're third-party financed, that these ECMs are in fact delivering the claimed savings that are how we're financing them, or we simply just deem that they're doing that, and because we assume if you install something, it will perform as advertised. This is a way of actually knowing. So super exciting technology, and I look forward to sharing this with all of you, actually to having our research team and facility operators share this all with you. So with that, I'm going to turn this over.
Hi, yeah, so this is Dylan Cutler, and I'm a senior research engineer here at the National Renewable Energy Lab. And me and Willie Bernal, who's also here with me, did the analysis for this report. Next slide. So just to kind of continue to provide a little bit of background, thanks, Kevin. I think that was a really nice framing of the space and why GSA was interested in it. Kind of the incumbent approaches prior to the kind of more recent development of some of these more innovative circuit level submetering approaches was either advanced metering infrastructure, or AMI, or kind of custom builds. And so starting with AMI, that's been quite successful kind of at the utility scale, providing kind of smart meters on lots of homes or buildings, businesses, and to some degree, it makes its way inside of the building, kind of at a more granular level to, submeter a whole chiller plant or something like that. But that's kind of where it stops, and that's partially because it's kind of expensive to procure and install and network. To kind of get down to these more granular views of energy consumption within the building. On the other hand, there has been the opportunity to kind of custom configure, current transformers have been around a long time. People have connected them to meters and measured the current flowing through them and used voltage measurements to kind of combine into a calculation to understand how much power a device is consuming. That isn't brand new technology, but traditionally they have been kind of one-off. Purchase each of these parts independently. Often you've had to kind of find your own data logger to kind of collect all that data, and it's hard to get it out of the building. So essentially, they just haven't scaled easily, and that in turn makes them quite costly on a per point basis. Next slide. So this slide just kind of bins a few of the emerging technologies, and we are going to focus this discussion on these, what we call full panel meters. But just to note, there have been a few different kind of directions that the technology has evolved, and they're a little bit tailored to different use cases, as you can imagine, and different business propositions. The full panel meters, what we're talking about today, this is the ability to measure, up to the entire number of circuits within a standard commercial panel, so up to 42 circuits. They're using typically a voltage tap to both power the meter and provide that voltage measurement to mesh with the current measurement from the CTs. Similar to that are these single circuit meters, but they're really focused on just getting a single three-phase circuit, and there's a meter that's going to have 3 CTs attached and kind of measure that one load. That might be the mains for the panel, so capturing the whole panel. So they have their specific uses. They're just distinct from these full panel meters in that they're targeting one load at a time. Wireless CTs, which will be discussed in the next call. As Andrea mentioned, these are kind of clip-on sensors. They don't have a voltage measurement typically. And we'll go into further depth with those. The accuracy is, there's a trade-off between easy install and accuracy. And then kind of a somewhat newer and untested, there's been a little bit of research into this space, and there's a couple companies working on it, but are these sensors that actually just stick on and measure current by magnetic fields. And so that's kind of a few of the emerging approaches to doing this in a more cost-effective and kind of efficient manner. So next slide. So this is kind of the overview of what we looked at and where we looked at it. So this technology was provided by Enertiv, and that first picture kind of has a shot of their meter kind of at the bottom, lit up kind of in the blue light under the text. Connected into the electrical panel via that conduit. And this was tested at the Salt Lake City Courthouse in Salt Lake City, Utah. We focused in on 2 large server rooms within the courthouse, specifically because we were interested in the overtime utilities billing use case, and if we understand consumption of those kind of 24/7 high power consumptive loads, can you incentivize folks to take energy efficiency actions, initiate ECMs in these spaces to reduce energy consumption and hopefully reduce bills for those tenants as well, and appropriately recover costs for GSA. So next slide. So I kind of described this, but to go into a little bit more detail, essentially what we've got here is a kind of a fully integrated system where you have kind of that blue box in the infographic is the full panel meter that Enertiv has provided, and it has the ability to put up to 42 CTs to integrate with that box. Those CTs are kind of pre-configured and have quick clips that, you clip the current transformer around the wires within the panel, and then those are wired down to quick clips that connect into that box, which is in a standard NEMA enclosure, and that both samples the current and the voltage from the different loads within that panel, and communicates those data up to the cloud. In this demonstration, we transmitted all of that data over a cellular modem. It can also be connected directly into the local area network on kind of an Ethernet connection. And then they provide an analytics front end, which is kind of that bar charts and line charts in the infographic, an analytics front end that has lots of features. I'll note that the focus of this analysis and review of the technology was more on the hardware and less on the analytics. We won't get deep into the what that analytics can provide, in part because the value proposition of those analytics vary greatly building by building and use case by use case, and also because GSA was more interested in provision of accurate and consistent data that could be used either in this analytics platform or in another. That was kind of the focus of this research, rather than has Enertiv come up with some really nice dashboards and kind of analysis features. I'll also note that this meter can be paired with various types of CTs, so those are kind of, you could select lower or higher accuracy CTs depending on the use case, and I'll get into that a little bit more later. Next slide. The M&V approach that we took was essentially putting the Enertiv system into that Salt Lake City courthouse to measure a number of devices, including computer room air conditioning units, the server racks, lighting, so essentially all of the energy use of the data center, including kind of the pumps and coolers that were providing kind of the HVAC, the expansion part of the compression cycle for the computer room air conditioner unit. So that was what was being monitored in that building, and what we did was install the Enertiv system and then install revenue grade metering on the exact same set of circuits for a number of the devices that were being monitored by the Enertiv system. And so that graphic there is just kind of a description of how we were installing the NREL submetering right next to the Enertiv submetering, and that was kind of our benchmark against which to compare the measurements from the full panel meter that was under review. And so this was power and energy data that was collected at 1-minute intervals, and we were kind of comparing those two systems over the same period of time for accuracy and completeness. Next slide. And so here we'll dive into some of the results. The first thing we did actually before going out to the courthouse in Salt Lake City was to test this in the laboratory here at NREL in the Energy Systems Integration Facility, where we have a number of test homes already installed with kind of existing submetering, revenue grade submetering, already monitoring those loads at all time. And so we put the Enertiv meter there to test, to capture the data, and we're able to cycle kind of a whole bunch of different appliances in a controlled manner in the lab. And I will note that was a residential panel, and so slightly different than the commercial application that we'll see next, but these were the results from the laboratory testing. You can see the reference signal is the black dashed line, and then the green is the full panel meter that was under evaluation. And you can see that this is capturing the signal extremely well, tracking it quite accurately. There's a couple places that there's deviation, but generally tracking both the absolute quantity and the fluctuation in the signal. Next slide. And so this is just a kind of a tabular presentation of the results from that testing across a number of the different appliances. And these were all kind of cycled on for an hour, taking all those 1-minute readings and then comparing essentially the readings from the full panel meter that we were testing to the existing submeter in the laboratory environment. The one obvious deviation is the lighting, the 240-volt lighting row 4. That actually, if you look at the power and then that it's supplied at a higher voltage, that is actually only about a half an amp of current running through there, which is below the low end of their accuracy specifications. So that one's kind of can't really be included under the observation of kind of the assessment of accuracy here because it's outside of the ranges that these were specified for. But kind of a total error of plus or minus roughly 2 to 3%, which is quite good. This is testing some fluctuation and kind of off kind of part load performance in a sense of the CTs, so that their actual specification might be less than 1% error, but that you end up seeing a little bit more than that because the load is fluctuating and it's a slightly different test environment than the kind of ANSI rating system that the CTs are tested under in laboratory environments that are designed for testing accuracy. So this is more of a live demonstration of the technology, but in a laboratory environment. But they performed quite well here, so they continued on to the field testing, and so that's the next slide, I believe. And so this presents similarly the computer room air conditioners. This is actually just one of those crack units that was under test, and looking at both a week of data and then on the left, and then a day of data on the right there. And so you'll note that we have 3 traces in these graphs, and so I'll explain why that is. The green, again, is our reference signal, what we measured with the revenue grade submetering that was installed by NREL. And initially we had the blue, that blue trace, which is for class standard. So that's kind of the standard circuit level submetering CTs that came with the Enertiv package. And those were actually kind of overestimating power consumption by about 15 to 16%. And you can note that they track the signal extremely well, but they're kind of consistently biased high. And so when we dug into that a little bit more to understand the root cause there, essentially what it is that the CTs introduce kind of a phase error in the current measurements, especially when there's low power factor for the device that's under measurement. And so these crack units, since they're very kind of motor driven, there's kind of compressors and fans, they do have a low power factor. I think they're down in like the 0.6 range. So, usually we want power factor up at kind of 0.9 or higher. These have, low power factors just due to the nature of device. And with the CTs, the kind of standard accuracy CTs, that phase angle error introduces an error into the power calculation. So what we did, Enertiv worked with us to kind of provide a higher accuracy set of CTs that reduce that phase angle error, and that's the red trace that's basically underneath or exactly tracking our reference signal. And so, one thing to take away from that is, for fault detection and diagnostics, maybe all you care about is whether a device is on or off or cycling too much or kind of just a general signal. Maybe those standard accuracy are just fine because they're giving you that information. But maybe for a billing type application, that error is too great. That was GSA's kind of perspective is if we're going to switch to, billing based on monitored or measured power consumption, we want tighter accuracy than that. And so these high accuracy CTs were able to combine with the full panel meter and deliver that. Next slide. And so this is basically the very similar information provided for a number of months. 2 months, 4 months for the standard CTs, and that's the total energy error for the month. And then once we installed the AccuCTs, which are kind of a type of high accuracy CT, we have 2 months of data for energy error on those with those CTs installed, and that we had basically under 3% error with that system. Next slide. So we wanted to also look into kind of one of those other use cases of identifying, using these to track faults and identify new energy conservation measures. So we kind of performed, had an audit performed of the data center that used all these data that were collected by this submetering system to assist in identifying ECMs. And we're just going to highlight one that was identified here that really, I don't think, according to the folks who performed the audit, this data is rarely available, and you would probably not have identified this issue without submetering data to kind of highlight it. And so what we're seeing here is the blue and purple traces up high are kind of the server loads, so about 10 kW, and then the red, orange, and green traces that are kind of bouncing around down below are power consumption of the 3 different crack units. And so what jumps out here is really that these units are cycling a lot, and that there's periods where they'll be, cycling many, many times kind of within a day and even within an hour, especially as you drop into that kind of last part of the graph or, where Saturday, all 3 units are on and cycling the entire time. What this identified was that the programming for these crack units, they can be put into team mode, but the way it was programmed is they wanted to have 2 as leads, so 2 always on and 1 lag that would kick on if one of them failed. And essentially there was just too much capacity for having 2 on that they would end up going into this cycling mode quite frequently. And so it was a pretty simple, couple hour intervention by the, the technology provider that came back and reprogrammed them to have 1 lead and 2 lag, so that there would always be, ready to spin up if that lead unit failed, but that really 1 would be on most of the time, operating at higher load. Next slide. And so this was kind of the analysis done after, letting the meters collect data on those crack units post kind of implementation of that reprogramming. And so you see power consumption in yellow for kind of the pre-retrofit, and what we're plotting is power consumption on the y-axis and the outdoor temperature associated with that power consumption on the x-axis. And then the blue diamonds are what happened after that reprogramming. And so you see this kind of consistent offset, across a wide range of temperatures that were reducing the total power consumption for serving that data center. It was about a 10%, 10 or 11% reduction in energy use, HVAC energy for that data center. Next slide. That was kind of a summary of a lot of the results. To switch over kind of onto the installation side of this, it was pretty quick. This photo is a picture of one of the electrical closets where it was installed. You can see the enervative boxes are kind of the square ones with a black kind of transparent cover. This took about 14 hours to complete. 5 panels, 96 different breakers. These were installed in high-end, low voltage panels with limited space, so kind of no concerns on, is it, 120 or 480 voltage kind of panels. The space constraint wasn't too bad. They do have to be tapped into the panel. You can see kind of between the submetering panel and the existing electrical panel, there's little pieces of conduit where the CT wires and the voltage tap run. So, this is obviously taking a professional electrician to do this work. They have to open the panel cover to clip the CTs around the wires. We didn't have to de-energize any systems during this install. This also included an install in the motor control center, which is kind of if you aren't familiar with what that is, it's basically circuits but at a much larger scale than kind of this smaller electrical panel enclosure. And so, a varied type of installation, and it included kind of interfacing with these cellular gateways and installing those as well. So pretty rapid installation, no real hang-ups here. It would probably be easier if they were able to connect directly into the Ethernet drops to provide the communication of the data out to the cloud. But we avoided that here. This was kind of this pilot. We didn't go through a full integration into the kind of cybersecurity considerations of integrating into the local area network. So we kept it isolated. Next slide. As I mentioned before, one of the things GSA was interested in is, more of the data provision and less of a focus on the analytics dashboard, though there was some, we did see some nice features there. Kind of to limit the number of dashboards or applications that a building operator would need to kind of interface with. There was interest in looking at the feasibility of integrating this into GSA Link, which is kind of an existing infrastructure. One of the main applications within GSA Link is something called SkySpark, which is, you're seeing a screen cap of it here. And so we actually used the API or application programming interface that Enertiv provides to automatically pull data from their database in the cloud and ingest it into SkySpark. We have an instance of that application here at NREL, and Willie actually did this work of integrating the API and automatically kind of continuously pulling the data from that database. So you have near real-time access to the data in an application that exists within GSA Link. And so what's pictured here is just, I wrote a quick kind of short cycling rule within SkySpark. SkySpark kind of facilitates fault detection and diagnostics. And what you're seeing here is that, there's the cracks these are, again, those crack units, and this was before fixing the short cycling issue. And, you could easily use this data to perform that short cycling rule, which is actually one that GSA, I think, already has in their library. And so if this data was in there, you'd be catching that spark and could go, investigate that issue and hopefully address it. Next slide. A quick look at the economics. So I guess a couple notes here. Pretty low cost total installed cost for these meters at Salt Lake City. And the one thing I would note is that there are annual fees for kind of hosting that data in the cloud and providing the analytics. And so very low simple payback, but a simple payback period, which is great, less than a year, excellent return in this case study. But I will just note that those recurring fees are something to kind of consider. They're not fully captured in a simple payback metric. But the technology was low cost, would pay itself back, the hardware side of it very quickly. And what we've shown here is the energy savings from that energy conservation measure, and then also a row on the savings from tenant billing. And so what we did there was we looked at how those crack units and the data center as a whole were currently being billed. And, that's basically due on kind of calculated on, the capacity of the different pieces of equipment and their assumed runtime hours, some kind of, decent calculations, but definitely not measured values. They're assumptions that have to be made to recoup that cost from overtime operation of these assets. And what we saw in this one example was that if you were billing on actuals, GSA would recover a lot more of the actual cost it took to serve those loads. They were being kind of conservative in how much energy it was expected to run those systems. And so there's a substantial opportunity from a GSA perspective to recover costs that they're paying at the whole building level bill, but aren't entirely recouping from certain pieces of equipment. So that's another kind of revenue stream. Next slide. So kind of lessons learned. I think we kind of hit on all of these, but just to recap a couple high points. The tenant billing, at least for the loads we looked at, it was important to use those high accuracy CTs to reduce kind of error in the measurements. They're a little bit more costly, but could easily still bear the payback and are worth it if it's heading down a tenant billing or submetering for billing application. It's important to size the CTs to the power levels, and that can be estimated by doing spot measurements with a meter. We need to identify wall space. These are small. The enclosure is only 7 by 7, square. So pretty small piece of equipment, but need to make sure you can mount it sort of near the meter to enable the conduit run, and avoid cluttering kind of inside of the panel when you're putting in the CTs. As far as kind of tenant billing at a kind of disaggregate floor space and bill based on kind of occupied area, that can be challenging because it's hard to know what circuits, they're not always perfectly labeled which circuits are serving which exact portions of the building. Hopefully they're pretty well mapped on the the circuit panel layout, but that's not always the case. And you can do circuit tracing, but that might be kind of expensive, especially for low load receptacles. So it's important to kind of define the monitoring goals. What are you really interested in understanding better before selecting how many of these you want to buy and install. And then a registered electrician is required for install. The spare breaker in the panel facilitates the installation because that spare breaker can be used for the voltage tap. And next slide. So these were kind of the use cases we saw. The overtime utilities billing for especially devices with high power consumption. There's just a lot of kind of room for opportunity there. And the other big one is, there's a lot of, GSA Link currently is focused on delivering fault detection and diagnostics for mostly HVAC because that's what's in a building automation system. That's what's integrated into that. Things like lighting or, data centers that aren't fully integrated into the BAS, those are whole sections of end use that could be integrated into a fault detection and diagnostics platform via the data provided by these systems. So some really interesting opportunities there. Next slide. And that's it. I'll hand it over to Tyler Cooper.
Thanks, Dylan. So I'm Tyler Cooper. I am a mechanical engineer in our Regional Facilities Management group here in Region 8. We'll go to the next slide. So as far as this project came about, we've had a number of issues with like the overtime utility from the tenant building side, and this was an obvious, the Salt Lake City Courthouse was an obvious candidate there. So kind of within that, well, the first idea we had was just choosing a targeted approach where you have potential for savings. So high operational cost equipment. As Dylan mentioned, we have a number of those crack units serving our data center, as well as the lever units that were providing the cooling to that space. So we knew that was high impact tenant equipment that we would be able to see savings in right away that we weren't seeing on our advanced metering system. So as far as that goes, as Dylan alluded to with the costs, one of the things we noted is not cost effective to install these on certain pieces of equipment, identify ECMs, and then move them separate to other locations in the building. That upfront installation cost ends up accounting for about a third to half of your overall costs. And it just doesn't make it cost effective to be moving them from location to location. With that said, in avoiding those transference of installation costs, we want to keep the meters in place when we are going through tenant building situations. It does allow for ongoing performance measurement each year, and then those costs are easily transferable to the overtime utility bills. Next slide. So in terms of the operator engagement at the courthouse, after this initial installation, the building management staff there wasn't able to bridge the gap essentially. So the meters are still in place, but we didn't end up paying the ongoing subscription costs because the number of issues. I think, as Dylan mentioned, with one of the primary issues was the interfacing. Right now we've got a lot of different platforms for viewing data. So in the ability to integrate into GSA Link and then making this data available on one platform makes it a lot easier for our end users. And then you avoid the issues with them not want to log into multiple platforms. With that said, too, we were able to identify some faults with how those crack units are operating. But with their O&Ms and how they tend to run our buildings, it's always good to have that ongoing verification, making sure equipment's not falling out of line. And then you've got that ongoing fault detection with these meters in place, which is an obvious benefit to keeping those versus installing them, finding your performance corrections, then moving on to the next spot. The other piece we mentioned would be renegotiating the ongoing fees. Ideally, once we had a higher number of these submeters installed there, we'd be able to negotiate a recurring subscription cost. That's a little easier to stomach, and then purchase that at a regional level or even national level, depending on the direction we took this. Next slide. So potential use cases, this kind of goes into a lot with what Kevin and Dylan said already too. We've got an ESPC project. We've got a couple in our region that are ongoing. What these submeters allow us to do is to go through, install those, and then you've got instant verification for how those specific energy conservation measures are performing within those contracts. And it makes the M&V piece on that a lot easier. And then we've got that ongoing year-to-year measurement versus trying to run complex calculations and track specific key performance indicators with those projects. So the other piece is data center metering. We didn't touch. We obviously measuring the power going to the data centers here. With new executive orders that allows you to have instant, allows you to get the power usage effectiveness or your PUE metering for those data centers. For a lot of those installations, it's not cost effective for us to go through and install those at the main meters, depending on how everything's wired in the building. So this allows us to go through and isolate specifically cooling equipment serving the space, as well as the actual equipment in the space, and gather that data. Then the last piece is US courts. One of the things that's come out of that is their desire to have everything metered. Within the situation with this building, we pretty much went through line by line with the courts and where they were negotiating with us as far as the runtime hours on all of their equipment, what the load percentages were at. And that was a constant negotiation throughout the entire process. So after installing these submeters, we were able to go through, give them the actual energy usage for all of their equipment, and then that kind of that quelled both sides as far as how much energy that's using, and knowing that the billing for those overtime utilities is accurate at that point. And with that, I'll pass it back to Dylan.
I'll go through this really quickly so make sure we have time for some questions. But basically, we just wanted to wrap up by kind of coming back to the fact that there's a number of different kind of directions that this general kind of circuit level submetering is evolving. We just discussed this first column, full panel meter. Then there's these wireless CTs, kind of a single circuit approach, and then these electromagnetic field sensors. I think what we've tried to do here is drop the use cases that were identified in the rows. And so, this technology that we talked about today really kind of met the needs across a pretty wide range of use cases. I think what's not clear just in the check marks is that maybe like for fault detection and diagnostics, you might not need full revenue grade, whereas for tenant or equipment billing, you might spec that. So those are some kind of nuances. There's other technologies that are going to do really well for just, lower cost and wide deployment for visibility of energy use and FDD, and there's others that are going to be better for kind of tailored equipment measurements. So that's what we're kind of getting into here, and hopefully we'll have a forthcoming publication that summarizes some of these trade-offs. And with that, back to Andrea, I guess. Or Mike?
Yes, hi, Mike.
Yeah,
Yes.
thanks.
And if anyone has questions, please go ahead and enter them there in the chat window.
And I'll get started. We've got 3 questions at this time. So Linda asked, can you explain how the submeters can be integrated with existing advanced metering systems that GSA already has, such as the Schneider electric meters? And then, I don't know if we can have Linda answer this, but Linda, do the Schneider meters port into GSA Link? That might help us answer the question. And then while Linda chats us to answer that question, I'll ask Ned's question. Will this work result in updates to the Unified Facilities Guide specifications on the whole building design guide? And Kevin, I think that's kind of more of a policy issue. I'd like you to take a crack at that.
Yeah. I think the answer to that is I'm not sure. That's an interesting question, Ned, and we'd have to get back to you on that. I don't actually believe that GSA is a real user of the Unified Facilities Guide. That's more of a DoD thing. I think, Ned, we should take this offline, and you should simply email me and we can review where to go.
Okay, thanks. I'll move on to Eric's question. If an upgrade or complete replacement of the building HVAC BAS is planned, should submetering work be postponed until BAS work is substantially complete? I don't know, Dylan, if you could respond to that.
Sure, I can take a crack at it. I think it sort of depends on whether how much kind of power consumption data you'll be able to get out of that HVAC upgrade. Like if you've got lots of VFDs that are going to be driving the equipment, and you can get power measurements, and you expect to kind of integrate those points, then you wouldn't need to have submetering monitor them as well. So that's kind of like one small example of maybe a consideration between kind of an HVAC upgrade and submetering. And then you'd also want to postpone it if you were kind of doing a lot of electrical rework along with that upgrade, because you know, you'd want the final kind of circuits you know, connected into the panels, and you know what you're measuring there as far as power consumption of the different devices. So maybe 2 small points. I don't know if that helps or not.
You know, Dylan, another thing I don't think we mentioned, and maybe it was more the case in the Denver project in Salt Lake City, but one of the things you have to do is some due diligence as you install these CTs, is the mapping of the circuits, because sometimes, you know, the circuits aren't correctly labeled or completely mapped, and so you do have to do or perform some due diligence. I don't know, Dylan, if you want to add to that at all.
Yeah, that was kind of, I touched on that maybe not clearly enough, and kind of the lessons learned is that there is, you know, you open up a panel and it has sometimes a handwritten panel kind of schedule that says, you know, circuits 1, 3, and 5 are this piece of equipment, and that may or may not be accurate. And if lots of kind of upgrades have happened in the building and they haven't all been captured there, that's a potential challenge. And you can do circuit tracing to identify where all the kind of what's connected to what, but that's maybe a little bit costly. So ideally, you've kind of kept up on understanding what breakers are feeding what piece of equipment, but sometimes that's not the case.
Great, thanks, Dylan. And then Jeffrey's question, do you find inaccuracies with measuring loads controlled by VFDs?
That's a good question. We didn't look at that in this study. I don't know the answer to that one because we didn't actually test those. I wouldn't expect that that would introduce a lot of additional error, but I can't say that for sure.
Okay, thanks, Dylan. And then Shad asks, are system subscription services the only way to go, or could similar systems be available without cloud service model?
Yeah, that's a really good question. You know, I think you could, you know, depending on the provider of this technology, you could try, you know, negotiate a way to have a on-site server that's receiving all this data and storing it. Whether that fits their business model and they're interested in working with you to do that probably depends. You know, GSA is a big customer, so there's some leverage there. But yeah, I don't know. I don't think they're the only way to go, but what we're seeing is the most typical model right now with a lot of these technology providers is that they're kind of providing this cloud hosting service for the data. Because it's kind of streamlines the whole process.
And then Sean asked, within these approaches, are there alarming functionalities we can use when units are exceeding base loads in normal operations? I'll take a crack at this one. Sean, I will tell you, and when you say alarming functionalities, I'm guessing when you, I'm going to liken it to overtime utilities. So when you've got overtime utility operations, or when you got operations that are operating out of normal expectations, can GSA bill for those out of tolerance levels? I will let you know that we did coordinate this study with portfolio management because they're very interested in the possibility of metering tenant loads specifically. And they were excited about this, and they had told us that from their perspective, from GSA's perspective, if they could see tenant metering in the plus or minus 5 to 10% range, they felt that accuracy level was adequate or acceptable for doing direct tenant billing from submetering. And so in an indirect way, answering your question, I think what you propose is a possibility. I can imagine it's got some policy and political ramifications. We have to change pricing policy, et cetera. But I think there is potential there.
Yeah.
And then why don't
a quick follow-on to that, and like specifically to like, can you trigger alarms based on exceeding an expected base load or kind of out of order operations? Yes. You know, that's functionality that's available in kind of the analytics that this technology provider has, and it's also available in SkySpark if the data was integrated in GSA Link.
Okay, thanks. You interpreted the question better than I did.
No, I think they're both useful.
And then I'll go ahead and tackle Linda's question. I'm going to assume, I'm not familiar with the Schneider electric meters, but I assume that those are ported into GSA Link, and so that's kind of, which as Dylan explained, utilizes the SkySpark analytics platform. And as we showed with this study, we could port our data from these smart submeters into GSA Link and that analytics platform. And so it basically, you're adding to the picture. And so assuming Schneider electric meter data is in there, we add this data in there. And it actually is another case in point. When in another project that we'll discuss in June, we submetered electrical lighting data. And typically that's not something that the BAS covers. And so what we found there is we were actually adding to the data picture that GSA Link typically undertakes. So the smart submetering systems can add to your complete building data picture, if you will. And in the case of GSA, of course, we would use the SkySpark platform to perform the analytics for that analysis. Dylan, I don't know if you have anything else you'd want to add to that. But.
Mike, I'll just say from our end that all of our Schneider meters are ported into the Schneider Advanced Metering database, and then GSA Link is pulling the data from that database over to its system, and then that's where it's being analyzed. To your point, we could definitely integrate everything over to GSA Link like that. And then I think with these, the big thing is how that data is being stored and then the communication protocol that it's using to make sure that it can be ported over to GSA Link. So that's from our region, we've been trying to go to a lot more open protocol software, so that way we're not running into those issues porting that data over.
Right. Okay, thanks, Tyler. Andrea, I think with that, we've answered all the questions.
Yeah, great. Thank you. Thanks to all the great presentations and for everyone for being here. So shortly you'll be receiving a survey, and we've had some issues with the software, so not all emails have been getting through. If you don't receive an email with a survey, please reach out directly to Michael Hobson. He can send you a survey. Completing the survey is how you'll be able to receive the continuing education credit. And if you're aware of additional related technologies, please again reach out to Mike Lowell or directly with other technologies. We're always interested in learning more about those. And any questions, reach out to Mike Lowell or Michael Hobson. And again, thank you all for being here. And please join us for another Submetering and Analytics webinar in June. Thank you.